Now, moving on to the first question of exercise 6.3. In figure 6.39, sides QP and RQ of triangle PQR are produced to points S and T respectively if angle SPR is equal to 135 degrees and angle PQT is equal to 110 degrees. Find angle PRQ. Now, moving on to the solution. He has given a triangle PQR with two exterior angles, angle PQT as 110 degrees and angle RPS as 135 degrees. If we observe clearly, he asked us to find angle PRQ. Here, we can easily find the values of angle P interiorly and angle Q interiorly as the exterior angles related to that are given. Thereby, by applying the formula that sum of angles in a triangle is equal to 180 degrees, we can find the unknown value PRQ. So now let us do the solution. That is, if we consider TR as a ray with PQ intersecting it at Q, angle PQR and angle PQT form a linear pair. Therefore, the sum of angles that form a linear pair is equal to 180 degrees. We can write angle PQT plus angle PQR is equal to 180 degrees, which implies angle PQT is given as 110 degrees plus angle PQR is equal to 180 degrees, which implies angle PQR is equal to 180 degrees minus 110 degrees, which is equal to 70 degrees. Therefore, we got angle PQR as 70 degrees. Similarly, if we consider at point P, angle RPS and angle RPQ form a linear pair. Therefore, sum of angles that forming a linear pair is equal to 180 degrees. Angle RPQ plus angle RPS is equal to 180 degrees, which implies angle RPQ plus angle RPS is given as 135 degrees, which is equal to 180 degrees. That implies angle RPQ is equal to 180 degrees minus 135 degrees, which will be equal to 45 degrees. Here we also got the value of RPQ, that is 45 degrees. We know two values of interior angles of a triangle, and here we need to find the other value, that is PRQ. We know that sum of angles in a triangle is equal to 180 degrees. We can write angle PQR plus angle RPQ plus angle PRQ is equal to 180 degrees, which implies angle PQR is 70 degrees plus angle RPQ is 45 degrees plus angle PRQ is equal to 180 degrees. That implies 70 plus 45 is 125 degrees plus angle PRQ is equal to 180 degrees, which implies angle PRQ is equal to 180 degrees minus 125 degrees, which will be equal to 55 degrees. Therefore, the angle PRQ required is equal to 55 degrees. Moving on to second question. In figure 6.40, angle X is equal to 62 degrees. Angle XYZ is equal to 54 degrees. If YO and ZO are bisectors of angle XYZ and angle XZY respectively of triangle XYZ. Find angle OZY and angle YOZ. Now moving on to the solution. Here the angles given are angle X is equal to 62 degrees and angle XYZ is equal to 54 degrees. Later he asked us to find angle OZY and YOZ. Initially, to find angle OZY, we need to find angle XZY, and as OZ is bisector of angle XZY, we can get the angle OZY. So we know that sum of angles in a triangle is 180 degrees. We can write angle X plus angle XYZ plus angle XZY is equal to 180 degrees, which implies angle X is 62 degrees plus angle XYZ is given as 54 degrees plus angle XZY is equal to 180 degrees. That implies 62 degrees plus 54 degrees is 116 degrees plus angle XZY is equal to 180 degrees. That implies angle XZY is equal to 180 degrees minus 116 degrees, which will be equal to 64 degrees. As we know that OZ is bisecting angle XZY, angle OZY will be equal to half times the angle XZY, which is equal to half times 64 degrees, which is equal to 32 degrees. Here we got the angle OZY as 32 degrees. Here, in order to find the value of angle YOZ, that is this angle, we need to find the values of this angle OYZ and angle OZY, and by applying the sum of angles in a triangle equal to 180 degrees, we can get angle YOZ. Here initially let us find angle OYZ, that will be equal to half times angle XYZ, as YO is bisecting angle XYZ, is equal to half times XYZ is 54 degrees, which is equal to 27 degrees. Now in triangle YOZ, sum of angles is equal to 180 degrees. We get angle OYZ plus angle YOZ plus angle OZY is equal to 180 degrees. That implies angle OYZ we got it as 27 degrees plus angle YOZ we need to find, and angle OZY we got it as 32 degrees, which is equal to 180 degrees. Okay. That implies angle YOZ plus 27 plus 32 is 59 degrees is equal to 180 degrees. That implies angle YOZ is equal to 180 degrees minus 59 degrees, which will be equal to 180 degrees minus 59 degrees is 121 degrees. Therefore, angle YOZ is equal to 121 degrees. Moving on to third question. In figure 6.41, if AB is parallel to DE, angle BAC is equal to 35 degrees and angle CDE equal to 53 degrees, then find angle DCE. Now moving on to the solution. Here he has given that AB is parallel to DE and angle BAC is equal to 35 degrees and angle CDE is equal to 53 degrees. Now he asked us to find angle DCE. Now he has given that AB is parallel to DE and we can say that AE is transversal. If we could able to find the angle CED with the help of AB and DE as parallel lines and AE as transversal, we can easily find angle DCE as angle D, angle C and angle E are interior angles of a triangle. Now let us consider the first case, that is AB is parallel to DE and AE as transversal. Here if we observe clearly, angle BAE and angle AED are alternate interior angles. Therefore they will be equal if the AB is parallel to ED. That is angle BAC is equal to angle CED, which will be equal to 35 degrees, as alternate interior angles are equal. Therefore we got angle CED as 35 degrees. Now in triangle CDE, sum of angles is equal to 180 degrees. Therefore we can write angle CDE plus angle DEC plus angle DCE is equal to 180 degrees, which implies angle CDE is 53 degrees plus angle DEC is 35 degrees plus angle DCE is equal to 180 degrees, which implies 53 degrees plus 35 degrees is 88 degrees plus angle DCE is equal to 180 degrees. That implies, now on transposing 88 to right hand side, we get angle DCE is equal to 180 degrees minus 88 degrees, that is equal to 92 degrees. Therefore angle DCE is equal to 92 degrees. In figure 6.42, if lines PQ and RS intersect at point T such that angle PRT is equal to 40 degrees, angle RPT is equal to 95 degrees and angle TSQ is equal to 75 degrees, then find angle SQT. Now moving on to the solution. Here he has given two lines, those are intersecting, that is PQ and RS at T, such that certain angles are given, that are, let us note down them. PRT is equal to 40 degrees, angle RPT is equal to 95 degrees and angle TSQ is equal to 75 degrees. Later on he asked us to find the angle SQT. In order to find angle SQT, if we can find the value of STQ, it will be easy, as STQ forms a triangle. And in order to find the value of angle STQ, if we are able to find PTR value, then it will be easy, as STQ and PTR are vertically opposite angles and those will be equal. And later it is easy to find the value of PTR, as in triangle PTR, angle P and angle R are given. Therefore let us consider in the first step PRT as triangle, and sum of angles in a triangle is equal to 180 degrees. We get angle RPT plus angle PRT plus angle PTR is equal to 180 degrees. That implies RPT is given as 95 degrees and angle PRT is given as 40 degrees plus angle PTR is equal to 180 degrees, which implies 95 degrees plus 40 degrees is 135 degrees plus angle PTR is equal to 180 degrees, which implies angle PTR is equal to 180 degrees minus 135 degrees, which will be equal to 45 degrees. Therefore, we got angle PTR as 45 degrees. Now, if we observe clearly, about point T, angle PTR and angle SPQ are vertically opposite angles. Therefore, they will be equal. Therefore, can write PTR is equal to SPQ is equal to 45 degrees. Again, if we observe in triangle STQ, angle SQT is to be formed. Therefore, by applying the formula that sum of angles in a triangle is equal to 180 degrees, we can write angle QTS plus angle SQT plus angle QST is equal to 180 degrees, which implies angle QTS is 45 degrees plus angle SQT is, which we need to find, plus angle QST is 75, which is given, will be equal to 180 degrees. That implies angle SQT plus 45 plus 75 is 120 degrees, which is equal to 180 degrees. That implies angle SQT is equal to 180 degrees minus 120 degrees, and which is equal to 60 degrees. Therefore, angle SQT is equal to 60 degrees is the solution. Moving on to fifth question. In figure 6.43, PQ is perpendicular to PS and PQ is parallel to SR. Angle SQR is given as 28 degrees and angle QRT is given as 65 degrees. Then find the values of X and Y. Now, moving on to the solution. Here he says that PS is perpendicular to PQ, that is angle SPQ is equal to 90 degrees. Now, if we consider in triangle PSQ, angle SPQ plus angle PSQ, that is Y, plus angle PQS, that is X, is equal to 180 degrees, as sum of angles in a triangle is equal to 180 degrees. Now we know that angle SPQ is 90 degrees plus Y plus X is equal to 180 degrees, which implies Y plus X is equal to 180 degrees minus 90 degrees, which is equal to 90 degrees. Let us name it as equation number 1. Again, if we consider another case, that is PQ is parallel to SR, we get QS as transversal, and here angle PQS will be equal to angle QSR, as they are alternate interior angles, that is angle SQP is equal to angle QSR is equal to X, as they are alternate interior angles. Again, to find the value of X, we know that X and 28 are opposite interior angles to the exterior angle QRT. We can say that exterior angle is equal to sum of two opposite interior angles, that is exterior angle is 65 degrees here, which will be equal to sum of two opposite interior angles, that is 28 degrees plus X, which implies X is equal to, by transposing 28 to LHS side, we get 65 degrees minus 28 degrees, which will be equal to 37 degrees. Now, substituting the value of x in equation 1, we get the value of y as y plus 37 degrees is equal to 90 degrees, which implies y is equal to 90 degrees minus 37 degrees, which is equal to 43 degrees. Therefore, we got the unknown values as x is equal to 37 degrees and y is equal to 43 degrees. That is the solution. Moving on to sixth question. In figure 6.44, the side QR of triangle PQR is produced to point S if the bisectors of angle PQR and angle PRS meet at point T, then prove that angle QTR is equal to half times angle QPR. Now, moving to the solution. In the first stage, let us consider the triangle QTR. In triangle QTR, we know that sum of angles in a triangle is equal to 180 degrees. Angle TQR plus angle QTR plus angle TRQ will be equal to 180 degrees, which implies angle TQR is half of angle PQR as QT is bisector of angle Q. That is, PQR can be written as half of angle PQR plus angle QTR plus angle TRQ can be written as 180 degrees minus angle TRS, which is equal to 180 degrees. That implies, as 180 is common on both sides of the equation, we can cancel 180 on both sides, which implies angle QTR is equal to, on sending minus TRS to that side, we get plus angle TRS, and on sending half angle PQR, we get minus half PQR. That implies angle QTR is equal to, now we can write TRS is equal to half times the total angle, that is TRS, as RT is a bisector of angle PRS. Now, if we consider angle PRS is exterior angle to the two interior opposite angles, that is angle PQR and angle RQPR, that is half times PRS, which is the exterior angle, can be written as sum of two interior angles, that is angle PQR and angle QPR. Minus half angle PQR, that will be equal to half times angle PQR plus half times angle QPR minus half times angle PQR. Here plus angle PQR and minus half angle PQR gets cancelled, and we are left out with half angle QPR. Therefore, the required proof, angle QTR is equal to half angle QPR, is proved.